Welcome everyone to the October 21st, 2021 Mare Cognitum virtual chapter meeting. So again, same agenda as always, a little bit about the society, a little bit about volunteer opportunities. Niklas is going to do his presentation and then we're going to talk about it. All right, so two things going on with the society currently. We're doing a vision, mission, and values meeting. We're trying to realign the society to figure out, what our mission should be and how we should go about doing it. We've had a couple of really good discussions on Zoom. It's not closed. If you guys want to, be involved, have ideas about what you think the society should be doing, just get into our Slack. It's a committee mission channel. We don't have the next meeting set up. It's not a standing meeting, so if you get in on that channel, you'll get the latest. And the other thing is we're going to have a working group meeting next week. It's going to be in Slack. And hey, everybody do me a favor and just mute your mics while I'm on and then while Niklas is on, and then we can unmute it and talk later. Thanks. Anyway, working group meeting next week in Slack. We're going to talk about Moon Miners Manifesto. That was our newsletter for a very long time. We've been trying to reboot it. So we're going to talk about the future of it. Are we going to make it free? Are we going to put it behind a paywall for members only? That kind of stuff. And then apparently we're going to talk about the next design contest. We have a whole bunch of domains that we own. We're going to talk about, do we really need all of those domains? And then some general housekeeping stuff. So everybody's welcome. If you want to get involved, have a say, see how the sausage is made. I won't guarantee that it'll be fun, but it might be enlightening. And lots and lots of leadership and volunteer opportunities. This month, I'm going to highlight that we have an open position for secretary on the board, one of the officers. Our secretary left, and we need to fill it. We'd like to have somebody who's been with the society for a while and is interested in actually helping us, run it. So contact me or somebody else, or get on a Slack and say you're interested. We'll definitely want to talk with you if you're interested. And since we're going to be talking about MMM next week at the working group, I thought I'd mention that we need people to help with MMM. We need, editors, we need people to create content, all that other stuff. So if that interests you, let me know. I'll let somebody else know in Slack. Okay, tonight's presentation. How small can a fully self-sufficient community be living off the moon? Niklas Jarvstrat, hope I said it right, is going to be presenting for us. And take it away, Niklas.
Yeah, let's see if I manage to share the screen to start with. Should be that screen. There.
Yeah, it works.
Yep, good. So Manifesto, which was my project name for 15 years. I have been quite passive the last decade though. And my name, as Ben said, is Niklas Jarvstrat, which isn't particularly easy for non-Swedish people. It's an ä, the first A is an ä and the last A is an o. Well, how small can a self-sufficient community be? This is a self-sufficient manufacturing system, right? Stone axe. Well, in order to make another stone axe, which you need because in order to make it self-sufficient, you need some raw materials, stone, a stick, something to tie it together with, which you can get from a deer, which you can hunt with the axe, I'm pretty sure, if you're good at it. But that's raw materials. It's still, the axe is the self-sufficient production system, but the axe won't go hunting by itself. You need something more. You need somebody to hold the axe. So you actually need humans as part of the self-sufficient system, which is obviously a good thing for space colonization, because then it is you have the people colonizing is part of the system, which is what you want, really. Now, having a guy in, he can't just live by holding an axe. He needs to breathe and have something to drink and have something to eat. So we add a couple of new raw materials, being air and water. We have already killed the deer, so he has something to eat. Now he actually needs a bit more stuff. He needs to cook the food, so he needs some heat. He needs some protection, so he needs a hut. He needs clothing, which he got from the deer essentially. And he likely needs a bunch of other tools as well to make the axe and to make the hut and to bring home the fur coat and whatever. So that is essentially the production system. Now, that's on Earth, obviously. Now, a minimum self-sufficient production system on the moon. Well, we don't have the deer, we don't have air, we don't have water, and we don't have forest. So essentially, we're left with the rocks. And we still need all the stuff to breathe and live. However, how do we get that, and what do we have on the moon? There's plenty of oxygen. There is metals. This is from the Lunar Explorer, I think. It's from the Apollo mission, and the stuff was brought back home. An average from that. It's a bit more iron in the Mare, and a bit of a difference, but essentially you have all of this. So you have oxygen, you have plenty of metals, you have some non-metals, notably silicon and plant nutrients. 0.5% doesn't sound so much, but it's actually pretty okay, except nitrogen, which is an important part of that. So carbon, nitrogen, and hydrogen you don't really have in lunar rocks. That's the issue. And from a study I made, I have a link to that, what I made, I initiated. I applied for a research project on a self-sufficient moon base in 1999 to NASA, Institute for Advanced Concepts, NIAC. They thought I was too few, being only me. So they suggested that I got somebody else on board. So I started talking with Orbitech, who was doing a fair bit of NIAC research. It's a company in Wisconsin. And they were interested in doing that. So we decided to make a proposal together, but then they changed the rules. So aliens couldn't be funded by NASA, which kind of makes sense. They don't want aliens in the space program. They want human beings, right? So Orbitech submitted my proposal essentially and got funded. And one of their main findings there was hardly surprising, that nitrogen is limiting, not because we actually need nitrogen for anything, but they assumed the normal atmosphere, and the atmosphere is mainly nitrogen, and oxygen is cheap, so nitrogen is limiting. And assuming 0.5% per day leakage, as the International Space Station has, you need about 400 metric tons of moon dust per person and day, which is a bit much. But then there is probably something like ice at the poles, which was known already then, and that will not just be water ice, it will be methane and carbon dioxide and stuff. And if you assume that it's roughly the same content as asteroids, then you get down to 100 kilo per person and day, which is still a bit much to process, especially since you have to go down into a very cold area to get it back. However, 0.5% per day is pretty leaky, so which can probably be improved by not having a space station and the weight limitations on that, but something that you can spend a bit of effort and materials sealing and keeping airtight. And also nitrogen is difficult, but there are cheaper gases. As 40% of the moon is oxygen, so we can lose a lot of oxygen without a problem. And if we replace most of the nitrogen losses, and we can get down to something like 1 kilogram per person and day, assuming still that it's essentially the asteroid composition of something near the poles. And that's doable, obviously. Well, obviously, maybe not obvious, depends on how difficult it is to get it anyway, but 1 kilo per day, you can sort of imagine that you can have a couple of persons to go out and get in 100 kilos, and that's per 100 persons, so should be okay. So we can actually get what we need from the rocks. We need to get oxygen out of it, which you can do by electrolysis or some such. You need water, which comes from this nitrogen-rich ice or some other source, but I do think that you need to find a place where you can provide water and nitrogen and carbon reasonably good. And you need some kind of agriculture, because you can't really, well, you can't hunt, so you need to grow the food in the habitat. And you need somewhere to sleep, which will obviously not be a hut out on the surface, but rather a room somewhere underground, really. So we still have the raw material and the production system. We will probably not eat meat on the moon, because that takes a lot of vegetables to get the meat. Fish is much cheaper. It's take about three parts vegetables and you get 1 part fish. So you could have some fish and vegetables. You wouldn't want to burn a fire indoors, so probably some other kind of heating system, probably electrical, which means that you will need electrical power. We'll get back to that later. You need to get the stones from the surface and in, so you need to break them or shovel regolith. And you need to have some kind of manufacturing system there. And you need some more tools, and my favorite tool is a welding torch, I think. Well, for this purpose, my favorite tool is a welding torch. I'm not a welder, so it's not something I have much experience of, but I think that's one thing we need to bring. And since I'm saying self-sufficient production system, if I bring a welding torch, I will also need to manufacture a welding torch. So that's really the base assumption, is that we should be able to have a self-sustainable manufacturing system, but we need to, so we can have whatever tools we want, but if we decide to bring in a nuclear power plant, then we need to have the tools to manufacture a nuclear power plant. So maybe we can find something that is more easy to manufacture, that still gives energy. I think solar panels is a good candidate there, or thermal. Minimum self-sufficient production system is what I tend to talk about. Material production, how do you make a colony sustainable materially? And this is kind of a typical time schedule for production on the lunar surface. You start by obviously landing in something that sustained you on the way there. So the first you just stay in it and live there. Then you want some more space. You bring some more space that you deploy, that you bring with you. Pretty soon you will want some more protection. So you shovel some regolith on top of it, or possibly find a lava tunnel. So you go underground, but you need to go underground. I'll get back to that a bit later. A bit in, you want some construction materials. It may be concrete that you can do from regolith, or just cast basalt. So you essentially use the regolith or the rock, but you make manufacturing, you make some solids of it that you can then use to manufacture at least parts of the habitat. Next step, I would say, is metal reinforcement, and then making things airtight is a bit trickier. It can be done with metal, but you then need to seal it in order to get in and out, which you do need, because otherwise you're kind of stuck in the coffin. And quite far out, and usually not really treated by discussions on how to make a colony or a base, is a fully self-sufficient in situ construction and production from in situ resources. What I'm trying to do, and I want to do, is to find out what do we actually need in order to become fully self-sufficient. And by fully self-sufficient, I mean no support from elsewhere, as in Earth. You have to find whatever you need from where you are. And we're talking about the moon here. I think that's the closest place. So why do I want self-sufficiency? Well, it's good to have a trade system going, isn't it? Yeah, I'm not saying we should cut off trade to Earth. That's not the idea, but I want to make sure that it is possible to be self-sufficient, and there's several reasons for that. One is that it provides an infrastructure backbone. Anything else you want to do is at additional cost, rather than having to build an entire base to start with. I tend to take as an example that nobody will get the idea to build a casino in the middle of a desert, right? But in Las Vegas, there is a lot of casinos, and that is in the middle of the desert. And it is because there is already a town there, and then it's easy to build another casino. I'm not sure casinos are the best application for a moon base, but you get the drift. It's also psychological security. If you know that if the supply ships has problems and don't come, you can still make it. You will not die if they stop sending you well, sandwiches or whatever. So that's the infrastructure backbone bit. That's two items on that one. And also having a self-contained society means that it's budget cut proof. If Earth decides we're not going to spend any more money on this, as has been decided before, then they can still survive, and they will probably make a living somehow. From business perspective, there's no recurring cost by definition of self-sufficient. So that's a good deal. You build something and then it keeps giving you stuff until they get tired of doing that. But you can send some microchips or something else cheap and light that they need, and it's difficult to manufacture in small scales as a trade goods. And then the third is more of a selfish reason. By requiring that it should be self-sufficient, and I avoid having to think about the buy or make trade-offs that would otherwise pop up. I have to, if I'm going to use something, I have to be able to make it. I can't choose whether I want to have M5 screws manufactured on the moon or not. And it's kind of easy to say that, but that dimension of screws, it takes too much extra effort to make that dimension of screws. So let's ship those screws from Earth. And since we're shipping some screws from Earth, let's ship all of them. So then you kind of lose the idea of being self-sufficient in the first place. It's better to start with a completely self-sufficient. So what I've been doing in order to look at how to become self-sufficient is to start with this guy with the stone axe. What does he need for survival? And I kind of said that before, is food, water and air, shelter, heat and light. Let's put in hygiene and health, because that's kind of a tricky thing to do on the moon, especially if you need some kind of operation there. So I'll just put it in as an important thing that maybe not the first thing to study. And then I want to quantify the survival needs as in these categories, and then continue making processes on that. So that will be quantifying the needs in terms of manual labors, raw materials, how much stone do we need to have, what type of equipment, how much pressurized space is actually needed. And for a start, this part of this comes from the NIAC study I mentioned earlier, and the part I found somewhere else, I think. It was 10 years since I did, well, it was more than 10 years since I did it, so it was a while since I had this table, but I think it's pretty conservative actually. Breathing air, 1.5 cubic meters. It's not that we use 1.5 cubic meters of oxygen really, it's that we use that much air that then needs to be replenished, sort of. Water, 7 liters. We don't drink 7 liters. That includes washing and laundry and dishes and whatever. Food, 1 kilo, maybe something like that. Pressurized volume, you don't need pressurized volume per day, so that's a total system. And if the colony doesn't grow, you don't need that to become bigger actually. It will kind of automatically become bigger if we get the rocks from underneath the soil. If we take them from the surface, of course, we don't create more space. Heat and light, 3 kilowatt. I think that's quite high per person and day, actually. I'm renovating a house, and I think that I calculate with 7 kilowatts for the entire house, when we're 4 persons here, as peak value, and obviously for that means a much lower average. So that was essentially quantification of the first level, and I'm not going to go into detail where that goes next step, but so this is the first level: food, water, air, hygiene and health, shelter, heat and light. And the middle bar here is the processes we need to produce that. Very high level, but I want to, and I've started a bit, trying to break those down in more concrete things that you can actually do. So food production, agriculture, you grow stuff. You have a water tank with fish in, and that will eat anything you don't cook from the vegetables. And then you eat the fish. Agriculture will also recover carbon dioxide to water and breathing gas, as in air, oxygen. Water goes from water synthesis, which then is essentially breaking up, taking the ice, and if it is water, then that's fine, then you just clean it. If it is hydrogen that's not in the form of water, then you need to burn it. There's plenty of oxygen, so yeah, you can combine that to get water. Water needs to be recycled and purified, obviously. Kind of the same thing with air. You need to produce oxygen and nitrogen and some carbon dioxide. Well, carbon dioxide you produce by breathing, so that's probably not a difficult thing to get. You don't need to actually manufacture carbon dioxide, I think. Yeah, air purification and ventilation. Hygiene and health, that's medical equipment, and make sure that the water and air is clean. Shelter, you need clothing and you need a habitat, so you need inner pressure tight hull and load carrying structure. Radiation and meteorite construction protection, about 2 meters of regolith, I think, is roughly corresponding to the Earth atmosphere. Heat and light, so power generation. So, and then what do we need in order to sustain these processes? And essentially it is agriculture, mining and mineral beneficiation, manufacture, energy generation, storage and distribution, logistics, and life support system and construction, if you group them roughly. If we then go on to the next step here, you could do that with each of them. I have only taken agriculture for now. You need soil, water, air, tools, heat and light, transportation to get things into the farm, including carbon dioxide rich air for the plants to convert back to oxygen, and some fertilizer and stuff. The agricultural parts needs be sheltered, of course, and then you need farmers. And if you look here, it is actually the same things here. It's mining and mineral beneficiation, it's manufacture, energy generation, storage and distribution, it's logistics and life support, it's construction. You add manual labor. You don't need manual labor to survive. You just need the results of manual labor. And you don't need agriculture for agriculture, but you get back to the same set of items or goods that you need, and you get back, and you consequently get back to the same set of processes. So by quantifying these processes, you have quantified the entire production system. Oh, these are the processes, sorry, these are the goods. So that's essentially the framework of the project. I'm trying to restart again now. So that this now becomes a production system effectively, and this is a different view of effectively the same thing, slightly different names on them, but starting from survival, we need air, food and water and that kind of stuff, which comes from life support consisting of farming and chemical processing. We need heat, light, energy, and rooms to be in and stuff like that, which essentially comes from manufacturing and power generation and transport, which are lumped in under auxiliary. And everything starts from mining, excavation, which could be breaking rock in a tunnel, making a tunnel and taking out the material from inside it, or it could be shoveling regolith from the surface. And then you have essentially the same process, which is volatile extraction and metal extraction. You take the rock and you put electricity through it or something less energy heavy, and you separate the volatiles from the metals essentially. You have metal oxide, so you separate the oxygen from metals, and then you get the input for the manufacturing processes, which then gives the manufactured stuff and so forth. So essentially, this is obviously what we're doing on Earth now. So what's the difference? And in principle, there is not much of a difference. Yeah, obviously I have the low gravity, it's 1/6 of Earth, which means that you have less downward force. Digging becomes awkward. You have flows, liquids move less because molds are usually you can pressurize. You need to pressurize mold filling if you're going to cast something, probably, because otherwise you will get more pores than you do here on Earth, and that will make the metal lower quality, less prone to breakage, fatigue and stuff. You have less convection, which means that heat conduction is lower. There's lack of some minerals. I've talked about that. Talked about hydrogen, carbon, and nitrogen earlier. Copper is also very little on the moon, but copper, I don't think that's that important. You can essentially replace it by aluminium or gold for conduction. Plenty of aluminium, not so much gold maybe. We will need small-scale solutions, not because it's necessary to be small-scale on the moon, but as such. But I think at least medium term, it will not be big cities of 1 million inhabitants on the moon. So I'm looking at smaller scale, kind of 100 to 1,000 people. Then you have the other environmental things on the moon: vacuum, radiation, meteorites. Vacuum is a pretty good thing, mainly. It's dangerous, obviously, so it's not, which is a bad thing, but there's quite a few manufacturing processes that are aided by vacuum. It protects from oxidation because there's no oxygen. Mining in vacuum, I suggest, because of the risk of finding a void that would then be a vacuum, obviously. So that will be dangerous otherwise. Depending on how good you are at finding out the structure ahead of where you're digging and the general structure, it could be that you can pressurize the working space, as Ben has suggested, with oxygen. Oxygen is cheap. Well, it takes a lot of energy, but there's a lot of it anyway. The houses or the habitat on the moon will not be structurally houses. It will be more like pressure vessels rather than buildings. The trick is to contain the pressure, not to keep the roof up, even though you need a couple of meters of rock to compensate for the magnetic field and the atmosphere. But the main issue, the main problem with the building on the moon is the air tightness is a key parameter. You need to minimize the air losses, and in particular the loss of nitrogen. So a good conclusion from all that is that the moon base will be underground, because then you have the structure and it's a good place to be. Design loads, I kind of talked about that, I think. Meteorite impact on moonquakes, yeah. And airtightness is the problem. This is the kind of the standard picture in media of a moon base. You have glass domes. Glass generally have low tensile strength, it's brittle, and it's generally pretty poor radiation shielding. And something brittle when somebody's throwing rocks at you is not a good idea. So I think there might be glass domes, but they will be for observation, pretty temporary. You go up there to have a look, and then you leave. You don't want to sleep there because that's dangerous. The next step that's also pretty common in literature, and was when I started as well, is what I call buried tin cans. You have a pressure hull and you shovel regolith on top of it. It kind of works, but you have to move a lot of regolith, and we know that's not that easy to move because it tends to get in everywhere and break stuff. And also to move regolith on top of something that the loads during construction is quite different from the loads under use, because, well, once it's there, then it counteracts the pressures, and that's a good load situation. But shoveling it on, and then the pressure hull needs to handle quite odd loadings. It would work. It might be early stage because you can bring a pressure vessel. Well, actually, you do bring a pressure vessel because you have some kind of fuel system. At least going from Earth to the moon, you might not need that in the lander as such, but since you have brought it to orbit, you could just as well land it, and you have a pressure hull that you could then let vent to get rid of the fumes, and then you have a good habitat. In case, but you still need to cover it with something. So I think what will happen is something more like a shopping mall, but underground. So you have a large corridor or common outdoor space. So the outdoor on the moon will not be up on the surface, it will be in the larger cavities. And then you will have apartments where you live, or where you have manufacturing processes going on in the walls. It's kind of simple, and since it is simple, I think that's probably one of the cheaper way of doing it as well. Some inspirational drawings that I have actually permission of patrolling to use. I haven't nicked them. This was on the previous page as well, and this is kind of a trench where you go down and go into the doors down there. I think that's not going to happen, and because that spreads out the width of the dome without anything useful. So close the gap in the middle and put those entrances on the sides instead. But it's a pretty picture, and you have a guy flying there, which you can do on the moon because it is low gravity. So this is probably a pretty realistic picture of how to fly on the moon. And that's that brings us into what you could export from the moon. People talk about helium-3 and metals, but metals is completely worthless because of the amount of it costs energy to bring them up anyway. Moon is lighter than Earth, but it's still. Early in the exploration of the solar system, you could export fuel, or at least oxygen. I would prefer to keep the hydrogen on the moon for the settlers there. I have been talking about it is possible to run, to have running tracks that go in a loop like that. This is actually something I found on YouTube. This is a photo of a guy doing that on Earth. So it is possible to do it in Earth gravity. So he runs through the loop there, and he stumbles a bit coming out, but it is possible. And they showed calculations on that, and I think it was 9 miles per second. Yeah, which is quite fast for running. I couldn't do that. So, but on the moon you get down to much slower. So comfortable running speed of 5 meters per second is will make you able to do this in quite a bit larger as well. This is kind of the smallest you can do, because the center of gravity needs to rotate in order to put the pressure on the upwards. As I said, you can fly, so you can do something air polo or Quidditch. I don't quite know how to make a broom fly, but you can fly by flapping your arms at least, and you can obviously find a kind of ball to chase. For ball sports, the main difference is that the balls will go quite straight. It will, the parabola will be 8 times as long, so anything realistic, the ball will be very straight. So you kind of need to, instead of having a table, you have a tube. So you have a net going around, and then you have a circular surface. You could possibly even run around here in circles while playing. Not quite sure how much of a spectator sport that would be. I'm getting a bit unstructured. Habitat design, I've talked a bit about that. You need to design tools, not just for making stuff, but for the kitchen as well, that you can manufacture. Outdoors, you will need quite a lot of quite a lot of area for growing the food. So I think that the thing to do there is to make sure that that is made also kind of a park-like nice place to be, so that you combine a quite large area that you will have to have anyway with making it look like outside. And one question I've been asking is how much nature do we actually use? Even if you go for a run in the forest, say that you kind of focus on a couple of meters near the path anyway, and if that is nice and pleasant place to be, then you could get the feeling of being in nature, even though it is in a rather contained space. And having 100 people and growing 400 people, that is that it will actually give enough space because of the growing plants. So that's one part. This is kind of this is a drawing of an underground lunar colony validator that I was planning in well, about 10 years ago, and I'm starting to pick it up again and trying to find out how to do it. I'll get back to that. So what I want to do is essentially to have the samples of the processes, the types of processes that I think are needed. So ore mining, workshop, metal manufacturing, agriculture, food growth under artificial light and with controlled atmosphere. So you can see that it is. There are things you can obviously not simulate the gravity, but you can simulate the production of the gases needed and of the soil. So you can have a soil that you have manufactured. Or mining shouldn't just be mining, it should be processing as well, so that you get things out of it. And then have a bit of architectural design of it as well. So you have habitats as they could be, and include corridors that could look like they could do on the moon, even though we will not recommend people to run in the loops. So these are my plans as is now. Keep quantifying the production needs. I have started, but it's rather sketchy, and it isn't really it isn't a connected flowchart with all the numbers and all the quantities, which shouldn't really be that difficult to do. So I'll get back to working on that, and starting to have some kind of production demo for validation. I have started looking at a location for a mine. I'm kind of done with the presentation now. I have some slides as well on what I did 10 years ago. So if I'm not stopped, I will continue with that. I would like to have a mine location. I was using an iron mine earlier, which I was intending to use an iron mine. We don't have any around here in Scotland, but there are a few basalt quarries. So considering trying to buy one that is not in use anymore, might not be good quality basalt, because that's not really necessary. And want to build the underground part of the habitat, kind of the shell, to start building useful sections on it, both for habitation and for production units. I'm looking at buying a Quonset hut and putting that up, and I need some money, which I think there is quite an interest in both space research and also self-sustainable, what you call, not self-sustainable, you don't call it on Earth, you call it environmentally friendly. You keep track of what's happening. So yeah, and to establish some income streams, using it as a think tank, since I'm building a rather an outdoor. I want to have the feeling of an outdoor outdoorsy cave, if that makes sense. So then it's a big room, and then you could arrange conferences as well, which is a good idea to get in people that can do parts of the processes that we need, because that will take a fair bit of quite common knowledge actually, but I would like to have experts that can tell me how to focus this so that it will work on the moon. Could use it as science and exploration themed hotel as well, because I want to have people living in a place which I think is what you could do on the moon with reasonably small space and things like that. That's not something I want to do, so I need a partner on that. But there are people spending a lot of effort arranging tours and hotels and stuff. And obviously, a moon hotel would be great for honeymoons. So I'll give, unless I'm running out of time, Ben.
Yeah, let's go ahead and wrap it up so we can have some time to discuss and everything. And
so I'll show two pictures. This is the mine that I had been promised to purchase, but then it fell on this is essentially in the area of summer houses. So although this is a cultural site, it is an old mine head. This is the mine head, and that is the iron ore beneficiation plant. So we had an architect that was doing the drawings for how that could be done. And at the 40th anniversary of the moon landing, we had an inauguration of it. I didn't get Buzz Aldrin, but we had his relative, Maria Aldrin. He is a Swedish descendant, you know, and it should properly be pronounced Aldrin, not Aldrin. I think they are related on her great-great-great-great granddad, or is the same person as one generation less on Buzz side. So that's me, that's Maria Aldrin, and this is the head of the local community. And we had presentations in the mine head. Well, that's not me, but we had made a stage out of one of the shaking tables for sifting the ore. So that is actually, that should be shaking, but we didn't manage to get that going. So we were standing on a rather stable table, actually. And we started the pumps. You might be able to see there is water flowing there to empty the mine of water. So yeah, I could stop there. I think that's a good place to stop. There's the mine head, and here's a map of the 110-meter level, and you have the same labels as I showed earlier.
cool. Well, thanks, Niklas. That was an excellent presentation. Very interesting. Could you stop your screen sharing, please?
I think so. Yes, I can. There.
Great. That way, for the recording now that's dropped, and now it shows the gallery.
Yep.
So, anybody have any questions or comments for Niklas? I'll start. Do you plan on having a website with all that information on it so people can go to it and review it at their leisure?
Yes, I plan on doing that. I have had one. I had moonisru.com and I have had moonmine.com. I will have moonisru.scop. No, wait, .space actually. moonisru.space. I own that site. I just haven't, but you can't look at it now because there's I haven't actually put anything on it. It's empty. Well, it's not even empty. It isn't there.
Under construction.
No, it isn't under construction. I haven't even started constructing it.
Got it. Well, let me know when you've got stuff on there that you want to show, and I'll email everybody in the membership and just let them know.
Yeah, I will do.
Anybody got any questions or comments?
Yeah, I would just basically ask, is the goal to build a self-sustaining lunar culture?
Yes, that's the long-term goal.
That's the long-term goal. Okay.
Yeah, my goal at the moment is to build a validator where we can test out pieces of it, and to make with two reasons. One is to do the scientific or engineering testing of pieces of process. My favorite is a welding torch to make a welding torch. So you weld the pieces of metal by just metal deposition. You put a string of metal and you put another string of metal, and if you keep doing that, you have a sheet of metal after a while. You will obviously need some insulators and stuff as well there. So it's not quite just the welding torch. You need something more.
Gotcha. A few years back, the company that I run, we did a project for a group called Rio Tinto. They're a mining consortium.
Mm-hmm. Yeah.
And we did a project for them in the middle of the Gobi Desert. And they were starting a brand new mining operation there. And our purpose was to go in and put some white papers together regarding supply chain management. Now, it wasn't as much the outbound materials, because they already kind of knew how to do that, but it was how to get everything from Hostess Twinkies to giant rubber tires for the mining equipment to keep the site sustainable. And that was quite the effort, because literally it was the middle of nowhere in Mongolia. I'm sure you guys heard that expression before. Okay. So when I look at what you're trying to accomplish on the lunar side, I think it's awesome. I think it's going to be full of a lot of challenges, but I just, again, building the torch, if you will, that's an awesome approach.
Well, I think you're right about that. I also think that one of the things we really need to think about when we're figuring out self-sufficiency and logistics and stuff is, what's a need versus a want? Because if we've got to deliver Twinkies to the moon, we've just made the job a lot harder than it needs to be. So yeah, if you figure out what is the bare livable minimum and then go from there.
If I could just add on to that little story, it was interesting because my team that was working over in the Gobi Desert, the mining company put up some domes that everybody kind of lived in for the short term. And it was interesting. They rationed everything from bathing towels, to the amount of water you could consume and so forth while they're building out all of the processes they have. And what was epic for me is I was supposed to make a trip to that facility, and it was in December or January several years back. And my colleague called me up and said, "Don't come." And I'm like, "Why?" I mean, I had everything all arranged. And he said, "You have no idea what they burn here to keep things hot." And I'm like, okay. And I went ahead and postponed that trip till later. But I thought that was interesting as well, because again, self-sustaining is one thing, but being able to make it continue with all the challenges, it's an awesome goal. I like it.
Yeah, that's kind of why I want to do it before we go to the moon.
Well, and there's, like you said, there are whole industries that are just based around, Earth-based logistics. So we don't have to start from scratch. We can look at examples about, how do you supply remote facilities and then go from there.
Yeah. Do you have a reference of that, Michael?
What was that?
Do you have a reference on that project? Because that sounded quite interesting, actually.
Well, I can, there's some material that I could provide, some I cannot because of our agreements that we have with the group we did this on behalf of. But I could pull some interesting things together.
Yeah, that would be great.
I will tell you this, what was funny is we were looking for a long-term relationship with that same group in Mongolia. And out of the clear blue, the Mongolian government came to us and said, "Well, if you want to continue to work here, you need to hire 13 employees." And, we were like, "For what? We don't need them." "Oh, yes, you do. You must hire." And their number for the size of our company was 13. And, we finished our project and had a lot of fun doing it, and then moved on to the next thing. I do have a lot of global experience in both the manufacturing and the supply chain industry, a lot. So, if you ever want to kind of touch base on that, from, not only the mechanics, if you will, of what goes on, but also the cultural components that are involved in it. One of the things that I teach my employees and my colleagues is, in any environment like this, we can never assume similarity. And that's between cultures as well as the businesses that you're dealing with. One business on one side of the block may have their own idea about how they want to do things culturally, but you step across the street, somebody else may have a different set of ideas. So.
Yeah. And it will, I hope it will be very international. I actually had at the peak of this project, when in 2011, I had 68 organizations from 20 countries.
Yep.
All over the world.
Hey, Nicholas, do you want to throw your email into chat so Michael and anybody else who wants to contact you can?
Yep. I'll try. Where do I find? I will do that. Yes, there is chat. I found it. You can keep asking questions in the meantime.
Yep. Anybody else got any other questions or comments? I think it's a cool idea. I think it's great. It should generate some great data.
One area I would look at is the question of the spacesuit. Most likely a hard suit. You're dealing with a fixed volume inside the suit, and so there's a lot of moving joints with that type of suit. But it's probably the most effective type of suit that you could use on the moon.
Yeah.
I've often thought, if you're talking about working on the surface of the moon, do you even need a suit? Could you get away with like a little pod on wheels using remote actuators? Anything to kind of remove all those fiddly joints and everything.
Or maybe you have an arm sticking out so you can grab stuff. Well, instead of having a robot control there, because then you have to build a robot. So you just have a shell.
Well, I mean, you could do it mechanically, little mechanical actuators. The problem with having the hands is, ask anybody who's ever used a pressurized spacesuit glove how fun that is after a while. It's just not effective for the current technology. So maybe instead of, because suits are going to be a problem because they're very high tech. They're made of materials that you're not going to find easily on the moon anytime soon. So maybe we need to rethink, do we need suits? Maybe there are other alternatives.
It's an area to look at. One thing I thought of is what I call the turtle suit. Basically, it uses a very large shell that you just kind of step into and then work with. There's some early spacesuit designs that way. And as a safety precaution, though, I also include the equivalent of more or like a mercury suit that you wear inside this. As long as the turtle suit is working, you're fine. If somehow you get tipped over, you then go to your mercury. You basically already dressed in your mercury suit and can exit your turtle suit, reset it upright, and then step back into it and get started again. So that's an idea.
What would you do about the dust, though? Because once you exit your suit, now you've introduced all kinds of dust problems.
Well, again, the idea is you're exiting the suit only in cases of emergency. And
right.
You could actually still keep the mercury suit on and keep yourself plugged into your atmosphere inside the turtle suit, so that dust wouldn't really be a problem because you'd still be protected by the mercury suit. But you're now operating in a pressurized environment with the mercury suit.
Right, but the dust has gotten inside your turtle suit now, and it's all over your.
Yeah, you have to decontaminate.
It wouldn't be a problem for you immediately, but it'll be a problem for you when you got to actually, leave the whole thing. I don't know. I'm a big proponent of avoiding the surface as much as possible.
That's probably a good idea.
The dust is going to be, I think people underplay how big of a problem the dust is going to be, especially for long-term use.
No, I agree on that.
But yeah, the turtle suit idea has been around for a very long time. It's cool that you actually introduced a secondary pressure suit as a backup. I haven't heard of anything like that before, so that's pretty cool.
Hey, everybody, I have to drop off. It's my birthday, and
Hey,
apparently the wife has plans. So anyway, all right, take care.
Congratulations. It's my birthday too, actually.
Is it really?
Yeah.
wow,
Oh, my Lord.
With you.
Okay. All right. Well,
I have extended my birthday by being on this meeting, because here it's not my birthday anymore because it's the 22nd.
Ah.
hey, could you pass me along those winning Powerball numbers? All right, everybody, take care. Thank you.
All right, thanks for showing. Thanks.
Thanks.
Bye. So anybody else got anything they want to add? Otherwise, we'll just wrap it up and Nicholas can go to sleep.
Yeah.
Okay.
Bye, all. Thank you.
All right.
And I'm still here if you want to chat for a minute, but I have to leave in 20 minutes.
Stay on, Michael, and we'll wrap this up and then we can just talk and I'll edit that out later.
Okay, cool.
Okay.
Thanks.
Thank you very much.
Good input.
Hey, thanks a lot, Nicholas. That was great. Learned a
Thank you
lot.
very much.
Cheers.
Thanks, guys, for showing up. Appreciate it. We'll see you next month.
Okay. See you. Bye.